Now that we have learned how to work with complex numbers, now we're going to be solving with complex numbers and looking at higher powers of I. Before we go into solving, I just kind of want to talk about how to factor with complex numbers. So looking at example 1, we're going to use our factoring rules. Let's look, and the first thing we notice is that both of these numbers are divisible by 5. So we have a GCF of 5 and can take out a 5. And I get x squared plus 4. Now, if I look at this x squared plus 4, we can think of a difference of squares. So remembering back, if I have a difference of squares, it factors to x minus a, x plus a. So here we're going to look at this x squared plus 4 as I want to look at it as a difference. But how do I get a positive? Minus a negative 4. So the positive is a minus minus. Now we can notice that this x squared minus negative 4 is a difference of squares. And we can use this. So I have x minus something and then x plus something. What are we adding and subtracting? Well, we're adding and subtracting a. Where did I get a? From taking the square root of a squared. So what am I taking the square root of? This is my a squared. The square root of negative 4 is 2i. I have negative 2i and positive 2i. So that's how I factor it. Let's do this similarly on example 2. There's no GCF. I look at the x squared plus 81. I want to look at it as a difference. I'm going to look at it as x squared minus negative 81. We have a difference of 2 squares. X minus, x plus. What is our a squared? Negative 81. So I take the square root of negative 81. I get 9i. So I have minus 9i plus 9i. And that's how we factor with our complex numbers. Now we're going to be finding all solutions. So this means we can have real or complex solutions. That means now we can take the square root of a negative number. The best way to do this, use quadratic formula. Are we set equal to 0? Find your a, b, and c. We're set equal to 0. A is 3. B is negative 1. C is 2. Let's go ahead and plug everything into the quadratic formula. I have negative 1 plus or minus the square root b squared minus 4ac all over 2a. Let's go ahead and simplify this. 1 plus or minus the square root 1 Negative 4 times 3 is negative 12 times 2 is negative 24. I have negative 23 all over 6. I now know from 12.4 how to simplify the square root of negative 23. This is going to be 1 plus or minus root 23 I over 6. And I am going to split this because I want this into the format of A. My A is 1/6 plus or minus B. My B is root 23 over 6 I. And that is what my answer is. I'd like you to now try example 2. Go ahead and pause the video. Give them time to try this. Okay, so we have A equals 1, B equals negative 4, C equals 5. Let's plug it in. Negative B plus or minus B squared minus 4 AC all over 2A. Make sure we're plugging in that negative, our B is negative. Make sure we're plugging it in with parentheses. We're going to simplify now. 4 plus or minus I have 16, and then a negative times a positive is a negative, so that's a negative 20. That gives me negative 4 over 2. From 12.4, I know how to simplify this. It is 2I. I'm going to now notice that all 3 of these are divisible by the same number, so I can reduce. 4 divided by 2 is 2. 2 divided by 2 is 1. So there is my answer. You could have done this one by completing the square, if you want. We have a value of 1 and an even B value, so you could complete the square. Now we're going to look at higher powers of I. Before we do this, I'm going to zoom in a little bit, zoom out. I want us to look at, higher powers of I. We're going to be doing I to the 27th, I to the 367. But first, I just want us to look at powers from 1 to 8. I to the first power is just I. I squared, we know from yesterday, is negative 1. I to the third, well, that's I squared times I. I squared is negative 1 times I. So that's negative I. I to the fourth is I squared times I squared. That's negative 1 times negative 1. This is 1. Let's do I to the fifth now. Let's break it down. How can I break it down? Well, this one's I to the fourth times I. What do we know I to the fourth is? I to the fourth is 1. That's 1 times I, so that is I. I to the sixth, we have I to the fourth times I squared. I to the fourth, what's I to the fourth? I to the fourth is 1. I squared is -1. So that's 1 times -1. We get -1. Are we noticing a pattern? I to the 7th is I to the 4th times I to the 3rd. Notice I'm always breaking it first into the 4th. Why? Well, we know I to the 4th is 1. I to the 4th is 1. I to the 3rd is -I. So I get -I. I to the 8th. I'm going to write this one a little differently. I to the 4th squared. Do we agree that this is 8? What's I to the 4th? It's 1. 1 squared is 1. So we notice that we're going in rounds of 4. These ones match. So if we look at 27, we need to think how many 4s can get us to 27. Well, if I had 5 times 4 is 20. If I have 6, this gives me I to the 24th. How many more do I need to get to 27? 3. 24 plus 3 is I to the 27th. What's I to the 4th? I to the 4th is 1. I to the 3rd is -I. I get -I. Another way you can think about it, 27 divided by 4 is 6, remainder 3. And that's where this 3 comes in. That's the remainder when we divide by 4. Go ahead and try number 2. Let's do it how I did it in green. What is 367 divided by 4? 91. And it's 91.75. So this is 91 3/4. So that means we're 91 remainder 3. So we actually might end up with the same thing. How would I write it with the purple? I to the 4th. How many times does 4 go into 367? 91. This gives us I to the 364. How many more do we need? 3. I to the 4th is 1. To the 91 is 1. What's I to the 3rd? -I. So the green and the purple are kind of two ways you can think about it differently. And that's how we work with higher powers of I.